Uh, Hello, Professor. This Alzheimer's data analysis is a project which we are going to present today. So Alzheimer's is a deadly disease. It's a brain-related disease which is faced by across all over the world among the age group people. So it is Alzheimer's is nothing but a person losing himself upon his age. It's because this it's a matter of his behavior, it's a matter of his memory, it's a matter of his thinking abilities. It's a worldwide disease faced by every country among their elderly people. So, if we go into the introduction of the Alzheimer's disease, there are many reasons for Alzheimer's disease because of its physical changes in the brain, and also because of his genetic, and also because of his aging. And there are many reasons why a person is being suffered with an Alzheimer's. When you consider what are the characteristics that will be exhibited by an Alzheimer's patient, is because of, there is a loss of memory and is loss of its doing of his mental ability powers, memory, thinking, and behavior. These are the three things that will be affected by an Alzheimer's patient is in terms of his memory loss, in terms of its ability to lose his thinking power, in terms of his behavior, which he will recollect to his past, which will be his lives his past scenarios and everything. So when we think about the cure of this disease, there is no a cure that has been defined so far by any medical board, by any medical association. So there is only the fact that has been established that if we had identified in an early stage, we can make steps to increase the patient's lifespan, the patient's lifespan and his expectancy and his healthy for how to lead his healthy lifestyle. If you go into the statistics of the Alzheimer's data set, there are around 2 lakh Americans that has been diagnosed with an Alzheimer's disease every year. And also, it is the sixth leading cause of death in the United States alone. So, if you consider the world in the picture, it's a whole different number of that. So, when you consider, why we decided the Alzheimer's data analysis upon our project is because the the prevention and the catching of the disease is the first priority of on in this disease case. So we decided to take upon this case and to find out how much possible a probability that a person can be held if his MRI image data and his personal data records and his personal well-being records are given with us. So then right now there are many machine learning models and machine learning algorithms that can predict that can diagnose a patient's Alzheimer's if he's prone to Alzheimer's by seeing his MRI data. But that's not our case, sir. We want to say what is the probability if he has been treating with this, even if he is being treated with the non-Alzheimer's, how much probability is he going to affect with his lifestyle? How much probability is he going to treat if he has exhibiting even one of the symptoms, sir? So for this, sir, we had taken the data from the OASIS, that is an open source access series of imaging studies, which is an openly published data, which is a clinical data of about 500 patients. They have published it over their website. So when we go into the see the website, let me show you the website source data, sir. Sorry. So yes, sir. So this data is published openly. This is a clinical data published of the 500 individuals, which is made available, for the for our research purpose, and also the Center for Disease Control and Prevention also acknowledged and published this data as a clinical data, which we can do the research upon this. So among this, the data contains of two types. They had published the data of about two kinds. That is longitudinal and also the cross-sectional data. That is, every brain has to be in the position. The data taken of an MRI patient is taken upon two stages. That is cross-sectional and upon his longitudinal data. In this, every patient, there are two factors to consider. Every patient has been diagnosed with two to three to, four, more than four times upon repetitive scanning of his MRI images. They even consider the number of visits, the MR delay to take in the delay, and the easy made for this is he right-handed or left-handed. What we see noticed in this data is every patient is a right-handed patient, and his age group is an education which education is studied, I mean, which grade, which classes, studies, transfer, social economic status, which you consider under which social economic status, I mean, which under which category. MMS stands for the mental stability examination given by the medical board, that how much a person or an individual is capable upon a few upon a few parameter exams. And CDR is a clinical dementia rating, which is also given by the medical board. I mean, there are four stages in an Alzheimer's patient. So that is mild dementia, dementia, and severe dementia, and mild symptom dementia, which is an which is a four categorical positions placed for an Alzheimer's patient, which we will be categorized based upon their physical examination, based upon their uh, personal examinations. And EQ stands for estimated total intracranial value, and NWV normalized core brain volume, and ASF as Atlas scaling factors, which we'll discuss about each of the factor why we are considering this in the presentation and in our model itself. So this is the data which we had collected from the websites and everything. So for this process, we had gone up with uh, data acquisition. Let just take a minute. So, so we had gone with the four stages in this process. That is data acquisition, data transformation, data analysis and prediction, and data visualization. So first, the data acquisition, which we had acquired from the open, it's an open source data, so there is no need to. So we did not have to. The data which is available for us. So we had used a Jupyter notebooks for our visualizations purpose and for the model building and for the everything. So which will upload all the code and related to all of them to a GitHub repository, which will make this public. So we had used pandas, C1, NumPy, and PyPlot for plotting and everything. C1 for the plotting images and everything. So first we had loaded the data using the pandas library into our data frame, and we had analyzed the data, like how the data is seeing, how the data is imaging, and how is the data and everything. So upon seeing that, we had do the data transformation. So first we need to see, is the data clean or not. So for that we had to use the data contains any null values or not. So as we can see, not every, I mean, every data is about the clean, but except the SAS, that is social economic status data, which is having the 19 null values, and MMS is a mental stability exam, which is having two null values. So if and also we have checked, is there any duplicate? So there's no, when we run that, there's no duplicate data and everything. So we had made the fillers, I mean, we had filled these positions with the median and mean position. There is no reason why we had selected the mean for a MMSC and median for SAS. Generally, we consider the social economic status should be a median value of containing of medium household. So we had considered the medium value for that, and mean value as a average value for every individual. So we had taken about that. And also there is also another factor which we had came up with. So that is in the longitudinal data, I mean, in the data which we had, the grouping of them has made non-demented, demented, and also as the converted. So the converted comes down, demented is an Alzheimer's prone patient. So that is the person suffering with Alzheimer's. Non-demented is a non-suffering with an Alzheimer's, I mean, it's not prone to that. And converted is a patient who is not who has been not identified as an Alzheimer's patient, but later on is an MRI images and with his behavior, he has been diagnosed with an Alzheimer's. So it comes under the converted category. For our, I mean, for our analysis purposes, we could not consider the converted as a whole separate category. So we had made the converted as the demented in the subpart. So when we see, there are around 70 individuals who has been non-demented and 60 individuals who has been demented, and only 10. So we had converted them with the demented, and we had converted and when we consider the number of individuals who has been with the male and female, if we can see, the percentage of the non-demented is equal to that of the uh, which has been it's in the equal ratio, but in the non-demented case, the female have been in the more category percentage, and which is also we had used violent plots for plotting the male and female the same ratios, how he is looking on and also upon our data set, so we identified that the 73 age group is more prone to this disease. That means the more people are we are seeing they're exhibiting more. Uh, symptoms and the characteristics at the age group of 73, and 62 to 63 and 1992 are the least number of they are experiencing the least number of symptoms and all. And while in plots of this of the same category, and the dementia and non-dementia fit contents of the same age group, we can see that the demented people are in the more of 70 to 80 age group, and non-demented in the 90 to 100 and the 60 to 70, they are the more less prone to the disease. And as I said, that social, I mean, the medical examination, which is contents of high score, contains a person is a normal and he is not prone to the Alzheimer's. So our data is also showing the same thing. If you can see, non-demented patient has usually the high score of MMSC, and if a person is suffering with an Alzheimer's and has been diagnosed, he has a least score, so which is an MMSC, the score individual of the person. And this is the different plots. We had drawn these plots to identify how much the relation, I mean, is the relation between the columns, I mean, the age groups, and with is and about his mental examination, and about his social economic status, and with his and with his we wanted to define the characteristics. Is there any correlation between the everything? So we had drawn the plots of these everything to identify the relation between all the columns and everything. And so we also, as we are building the machine learning algorithm, we want to know how much is the correlation between the columns, so that we can make our parts easily. So this is the correlation chart that we had come up with to discuss about the columns and to relation between the columns and everything. We know that the the values ranges between +1 and -1. +1 is usually stands for the more correlated, and -1 is negatively correlated. And this is so for our modeling purposes, we had gone with 70% as our trained data and 30% as in our testing data. So this is the function. I mean, the function, the definition for the training of the setting of the data, and the metrics which is used for the plot confusion metrics, which we had identified for that. And this is the model, and this is the reporting performance, which we had designed the code for the efficiency of the model. And so there are different models that are these are the libraries which we use for our code. And we had, so there are different models which we can predict upon a patient's analysis upon the reports. But we had gone up with the three machine learning models, that is SVM and decision tree classifier, and also with the XGBoost. So why we had put these three? Because when we plot with the different machine learning algorithms, we come up with these things having the highest accuracy model. So when we had identified, and we had when we had done the machine learning algorithm with this data, we had find out which is having the highest accuracy with the 77%. This is the confusion matrix that has come up with this data, that is 46 out of 6 and 19 out of 41. And that is true positive, true negative values of 46, false positive as 6, and false negative as 19, true positive of 41. So with this, we can, it's an accuracy of 77 points, I mean, something near 7.776%. And decision tree classifier, when we run this same code with the decision tree classifier, it has come up with the 79.46% of the accuracy rate, and XGBoost, which is came up with an accuracy of 83%. So among these three, we had identified these three are the exhibiting the more accuracy percentage, when we had come up with the 70% of the testing data and 30% of the of the test case data. So this is these three algorithms are being more prone. I mean, are being more interact. I mean, more correlated with our data and everything. So we had come up with these three classifiers which we had. So whenever a person has been diagnosed with a patient data, we will say that what is the probability which we can what is the probability that a person can be and how much probability the person can be diagnosed. I mean, how much probability the person can be prone to the Alzheimer's disease or not. This is our project, sir, and this is our this is our deeper analysis upon the Alzheimer's patient and with the characteristic data. Thank you.